Hello everyone, welcome to the IBO, where we talk about math and hope we get a 7. So hello everyone, this is North American Math Contest Go Go Go. Today we are going to talk about arithmetic sequence, which is the first lesson of every single IB student must suffered or learned. Yeah. You know, like as the 24th, like what I say that M24, they are going to start. This video is going to be very crucial for them because they can use it to they will learn it, I think, as soon as their IB life starts. So I believe it is very helpful for them. Let's begin. So what is an arithmetic sequence? Let's first define sequences. Sequences defined as a list of numbers. So for example, we call this is a sequence, but this is not a sequence. So we now know what the sequence is, and we know the number within a sequence is called a term. So for example, this is a term, 1 is a term, 2 is a term, 3 is a term. A sequence can be either finite or infinite. Finite sequences means that the sequence is not endless. Infinite sequence is the opposite of finite, which means it is endless. So I'm going to give you a quick example. Finite, 1, 2, 3, 4. You can see there's only 4 terms, 1, 2, 3, 4. So it's finite. Infinite, the easier way to change finite into infinite is just to add this. Because we don't know how many values, how many terms there's going to be after the number 4. So usually, IBO usually denotes a term as an. So, for example, the first term is A1, the second term is A2, the third term is A3. An is defined as the nth term. So, for example, n minus 2 is going to represent the n minus 2's term. So, now let's talk about arithmetic sequences. Arithmetic sequence is a sequence with the same value of differences between two neighboring sequences. An example of the arithmetic sequence is going to be 1, 3, 5, 7. Why is 1, 3, 5, 7 an arithmetic sequence? Because as you can observe, like each two neighboring sequences has a difference of 2. So for example, 7 minus 5 is 2, 5 minus 3 is 2, 3 minus 1 is 2. And in this case, we would 1, 3, 5, 7, etc. is going to be the arithmetic sequence, where 1 is the first term, 3 is the second term, 5 is the third term, etc. So a common formula for the arithmetic sequence is this one. An is equal to a plus n minus 1 d. So where a is the first term, the value of the first term, d is the common differences between the neighboring sequence. In this case, the d is going to be 2. N is going to be the number of terms in a sequence. So in this case, if we have 1, 3, 5, 7, it will be 4 terms. So for example, A7, it will be A plus the 7. We know like A7 means the 7th term. So it is 7 minus 1. It is 6. So the formula for A7 is A plus 6D. So let's see. In this case, the first term is going to be A, the second term is going to be A plus D, the third term is going to be A plus 2D, etc. After we know how to represent an arithmetic sequence, let's talk about the sum of them. So there is a common formula for the sum term of a finite arithmetic sequences. The formula is Sn is equal to n divided by 2, 2a plus n minus 1d. So where we denote n as the total number of terms, a is going to be the start term and d is the common differences. Now we are going to talk about how to prove that. So we said Sn is equal to sum of the series, so it is equal to a1 plus a2 plus a3, and we represent Sn like this, and Sn like this. So it is two identical sum of the series, but it's just placed opposite, like in reverse order. So as you can see, this is a plus d plus a plus 2d. This one is the last term, like it just adds into a plus 2d plus a plus d plus a. So those two are still the identical things. It's just the order changes, and they are both n terms. Why? Because the first term is a plus 0d, and the last term is a plus n minus 1d. So it's from 0 to n minus 1, there is n terms. And then we add those two equations, equation 1, which is this one, and this one. We add them above, we can obtain something called 2Sn is equal to a plus n minus 1d plus a plus 2d plus a minus 2d. So think about this like this. This is one term, this is one term, this is one term. And surprisingly, you can see that each term adds up to a plus 2a plus n minus 1d. 2a plus n minus 1d. You can see this one, it is equal to this. This one, it is equal to this. If you try adding them up, you will see like every term is like this, which again is a total of n terms. Because each term needs to match up with this one. Like this match up with this match up with this. So each term of Sn needs to match up with another Sn, like another term in the Sn above. So it's still n terms because there's n groups. By adding them up, we can see that we receive this formula of this. We combine them because it's added n times, so it is equal to this, and then it is equal to this. Now let's talk about the question. This question is going to be important because it may, it's one of the common problems in IBO. So the NCA salary of an employee is $10,000. Each year there's a $2,000 increase. We are required to find that at n equal to 1, the year that the employee's salary will be $50,000. So how can we do this? So we know that there is a 2,000 increase each year. So we know that the sequence of the money is going to be an arithmetic sequence. So because we know that n is equal to 1 means the first year. So this means that this is going to be the first term. $10,000 is going to be the first term. So A1 is equal to A is equal to 10,000. So we know this formula. This results in D is equal to 2,000. We then know that we then know the common formula of the arithmetic sequence is an is equal to a plus n minus 1d. So this results in, that since it says that we are required to find the term where employee salary will be 50,000, so we know an is 50,000. D is a common difference. A is the initial value. So we have 3 of them. We can just use this. We can just substitute them to the an common formula, and we can obtain n. In this case, we can obtain this, and then this, and then this. N is equal to 21. For the second problem, the solution is very similar to the first one. So we know that n is equal to 3, so this represents that $10,000 is the third term. And then we know that the third term is equal to a plus 2d as from here, right? And this formula. So we know the third term is going to be a plus 2d. It's going to be equivalent to 10,000. So a plus 2d is equal to 10,000. We know that there's a 2,000 increase, so d must be 2,000. And a plus 2 times 2,000 is 10,000. A is 6,000. So we know the initial value, which is the first term. And then what we do is that we plug a, which a is 6,000, an, which is the final value. In this case, is going to be 50,000, which is, yeah, here it is, 50,000. So we plug in those 3 values, a, d, a, n, and we can use those 3 to obtain this equation. And then this equation can further help us to find n. Now let's talk about another common strategy for arithmetic sequence. So we know that in an arithmetic sequence, if n is odd, even it is equal to this. If n is odd, it will be equal to this. How do we obtain this common strategy? I'm going to further intuit to you. A1 is equal to A. an is equal to a plus n minus 1 d, right? a2 is equal to a plus d. an minus 1 is equal to a plus n minus 2d. So as you can see that n minus 1d, a1 plus an, it adds up will be equal to this. a2 and a minus 1, if you add up, it will also be this. So if you try to put them, put each, you can prove that by separate each term of an into a plus n minus 1d form. And then after separating every term, you just add a1 and an up, a2 and an minus 1 up, a3 and an minus 2 up, and you will find that everyone is equal. Or you can use the same thing to prove it. Now I'm going to give you another example. So we are given a sequence of 3 terms. So they are 2x minus 1, which is the first term, x squared minus 3, which is the second term, 11 minus x squared, which is the third term. So this means that the sequence is, this doesn't mean, like I said, that it is an arithmetic sequence. We are going to determine the second term. So how do we solve this? We can use this formula, and we know that 3 is an odd number. So a1 is equal to a3, a2 is equal to 2a2, right? So we know that a1, because we use this formula, a1 plus a3 is this one, a2 is this one, 2a2, right? So we know this. And then we plug in a1, a3, and a2. We obtain this formula. Those steps are just relatively simple because they are just expansion right? They are just expansion of each term. So after expanding, we move them into a quadratic equation, 3x squared minus 2x minus 16 is equal to 0. So this means that the 3x minus 8, we can do a quick, simplification, where we can get 3x minus 8, x plus 2 is going to be 0, and we obtain the 2 possible values of x. And then what we need to do is we only need to plug it back to the second term, and we are done. So this means that plugging them to the second term, we can obtain the value of it. Here we come to the end of our lesson, and I hope you have learned a lot. See you next week. Bye-bye.